Hi team, this is lesson 4, unit 6. This is your Tuesday lesson. Your T-TED for today, today we're using multiplication to find and identify equivalent fractions. And our T-TED for today is I can create or identify equivalent fractions by multiplying a fraction by a factor to equally increase the amount of parts. So it's the same as yesterday, except today we're in the abstract. Today the questions that kiddos are going to ask themselves are what is my original fraction? What factor can I multiply by to create an equivalent fraction? Why does that work? And what is the new equivalent fraction? We're going to use both visual models, pictorial models, and the abstract today. So today with our opening problem, again, they have to make sense of the problem first. Sarah ate 6/8 of a small mushroom pizza. Danae ate 14/16 of a small pepperoni pizza. Did they eat the same amount of pizza? So I'm going to do one thing first. I'm going to start with Sarah today. Sarah, and I want to see how they created their visual. Okay. Sarah, and they'll probably all do eighths down like this. So I'm going to do what I think that the kids will do. I don't know why I made this visual look like this. I regret it. So this is going to be 6/8. I'm going to label it along the side. I'm going to shade in. I'm probably not going to put unit fractions in all of those because it's a waste of time. And then I know from yesterday, I'm seeing what fraction is equivalent, and I know I'm going to 16ths. And so I have to create the same fraction as above. That's why my visual model is actually not good. And I need to see if I break this into smaller equal parts, 3, 4, 5, 6. If I partition it equally right now to get 16ths, does this equal 14/16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So to partition Sarah's to find an equivalent fraction, I get 12/16. Whereas Danae's, and I'm going to put Danae's down here, is actually decomposed to the 16ths. I'll go half first, quarters. That's what I should have done up above. I would have made it cleaner. And she actually has 2 more parts. That's 8, 9, 10, 11, 12, 13, 14. They are not equal, and I can explain that because the equivalent fraction is actually 12/16 for equal parts. She has 14/16. I need to put that label here. So right now I know that's not true. What I also know is that right here, to go from 6/8 to 12/16, I actually partitioned and created twice as many pieces. If I'm using twice as many pieces, I'm partitioning into twice as many pieces, I could multiply by the factors. This is always going to equal 1 whole, but the factor 2 to get twice as many pieces. I'm asking myself, how many equal parts did I partition it into? Twice as many pieces. What's the original fraction? What factor can I use to represent the partitioning? Twice as many pieces. If I did this, thrice or 3 times as many pieces. And then what is the equivalent fraction? How do I know they're equal? They take up the same amount of space in the whole.